It is the word is a global village. Everything is open for everyone. Again, but that because of this some policies of the USA, because USA is a big market for all. Because of the policies of the USA, again they are moving towards some protective policies. So that is one challenge. Okay, but usually secondary steel sector, they are not focusing on that. Possibility of demand slowdown in China may encourage dumping of steel. Although on the one hand, we are hearing that China is cutting the capacities every year, say 100 million ton capacity it will cut. But that is only half truth. They might be cutting the capacities, but only of inefficient units, but side by side they are increasing their capacities in the efficient units. That is one point. Global excess capacity is a threat, yes. We have to see that market areas also, explore the new market areas. GDP percent change, the policy packages to boost growth. That the Minister of Steel and Secretary Steel, they have already talked about that. So I need not again repeat those things. Growth-oriented policies, that Ministry of Steel has clear-cut plans for the growth-oriented policies. Rural consumption, that Ministry of Steel is working very hard to increase that steel consumption in the rural areas. INSDAG DG is here, and they are also promoting that steel consumption, particularly in rural areas. Operational opportunities, then significant growth prospects, global steel consumptions. This is all regarding that database which was collected by JPC, and I had the opportunity to present on behalf of JPC. Yeah. Can we have the next one? And now the technical presentation will start. And incidentally, that is my presentation. Yeah. Paramjit.
The next presentation would be on the technical and innovations in the secondary steel sector. This will be, you can say, Mr. Vishwabandhuji's original presentation. So I'll request Mr. Vishwabandhu to take up the pledge.
Yeah. Yes. Next. See, I'll speak on some of the technological developments and potential of technological initiatives in secondary steel sector. Let us first understand what are the sub-sectors of secondary steel or the mini steel sector. We have the mini blast furnace because normally it is said that below 1 million ton capacities is a secondary steel sector or the mini steel plant sector. So they have mini blast furnace also steel sector. There is a wide difference between the uses of the raw material, because these major producers or the integrated steel plant producers, they always start with the iron ore and the coal and the coking coal, the raw material which is available in the nature. But the secondary steel sector mostly depends on the scrap and to some extent DRI, which is made from the iron ore. So this is the iron making stage, either by the blast furnace route or by the DRI route. DRI could be a gas based one or the coal based one. We have in this region, Maharashtra region, we have the gas based plants also. But everywhere else, except in near to that Bombay coastal line, everywhere else it is the coal-based sponge iron. Both have their own advantages and disadvantages. And then the steel making, main, the arc furnace route and the induction furnace route for the secondary steel sector. And primary steel sector is making by BOF route, and then it is casted in the continuous casting machine, although some of the units still using ingot casting route. very inefficient route. Continuous casting with, I am very much pleased to see that more and more number of units, they are installing continuous casting and going for direct rolling. That is a very big the technological development or the innovation which was done in 2012 or 13. And today it is adopted almost by 30-35% units all over India. This is a great great thing for this sector particularly. Yeah. Then the rolling mills. Yeah, this is about the blast furnace plant. Blast furnace is the domain, what we thought earlier, that blast furnace is the domain of the primary steel sector or the major producers. But in the secondary steel sector also, that units have started installing mini blast furnaces. And they get the advantage also for that. Second thing is sponge iron, natural gas based, synthetic gas based. See here in India, you must have heard the name Jindal Steel and Power Limited, JSPL. They have done a very innovative experiment, and later on they assimilated that technology. Nowhere in the world, I am repeating, nowhere in the world that technology is available, and that is producing sponge iron by gas while using no natural gas. World is producing sponge iron mainly by natural gas. But in India, we have a very limited availability of natural gas. And geographical location problem also, because it is not available everywhere. So what the Jindals thought is, they installed that plant at Angul. There it is a huge amount of coal is available, non-coking coal. So what they thought is that why don't we use that non-coking coal which is available in plenty and at a cheaper price and convert it into gas, and then that gas is used in gas-based sponge iron plant. See, individual technologies were available. Gas-based technology based on natural gas was available, and was available, as well as coal gasification technology was available. But Jindals, they have assimilated both these, fusion of these two technologies, and they came up with the synthetic gas-based technology. That is what is the innovative practices and the adoption of these technologies. They were in the big sector, they could do it, but for secondary steel sector also, there are some innovative technologies which can be developed. And here I think because Ministry of Steel, they have promised to help all these innovative technologies. So we can take that their help for that. Synthetic gas based. Coal based, we have rotary kiln and tunnel kiln. Tunnel kiln technology also is was adopted by few units, but due to some reason or the other, although the technology wise it is a very good one, but due to some reason or the other, but due to maybe maintenance point of angle, they could not succeed that way. So selection of process depends on availability and cost of raw material and overall techno-economics. Okay, this is the sponge iron kiln, and Raipur sector. I see lot of people here representing Raipur sector. Raipur sector is very far ahead as far as this integration, mini integration of steel plants is concerned. They have adopted this installed coal-based sponge iron, and right from 2004-2005, and then spread to the Jharsuguda area, West Bengal area. So this sponge iron kiln that makes you available that coal-based sponge iron. So the availability or the dependability on scrap is reduced considerably. That is one of the biggest advantage of it. So DRI process flow chart. if we want to have some more value addition in our product, so we can start with the pellet plant also. Secretary Steel, she was also mentioning that regarding that pelletization. Because we have huge quantity of iron ore fines available with us. Earlier, some 5-6 years back, we were exporting all the fines, sponge iron, this iron ore fines, almost 100 million tons iron ore fines we were exporting to China and Japan. Why not we utilize ourselves? So why not this secondary steel sector also comes up? In Raipur area, yes, they have come up with plant capacities as low as 0.6 million tons. So one good area for backward integration. Then again process flow line for that sponge iron. Nothing is waste, everything is utilized. Yeah, this is a animated figure for sponge iron kiln. Okay. Yeah, now this coal-based sponge iron we must analyze, because everybody almost in, although people have the sponge iron units or don't have the sponge iron units in their units, but almost everyone is using some part of the, some percentage of sponge iron in their induction furnace, okay, and in the arc furnaces also. But while using the sponge iron, you must analyze thoroughly. Being the entrepreneurs of your unit, it becomes your duty to analyze. Don't leave these things to the shop floor people, but you must analyze yourself that how can I, while using this sponge iron, what factors should I look in for the techno-economics of my process. So that are the some factors: FEM, FET, FEO, gangue content, carbon content, sulfur content, phosphorus content. These must have to be looked in. And the physical characteristics also, that particularly the size part. Okay, some characteristics here. I am not going into the detail of it. That will be of interest for the sponge iron people. Waste management in DRI, very important. See, now earlier, some 1 year back or 1.5 years back, all the char, it was recycled in the power plant. Okay, whatever char was generated, it was recycled in the power plant only. But now the concept is that you separate the char by screening and plus 5 mm. The people who have the sponge iron units with them, it is good for them that separate the char, screen the char, and plus 5 mm. It is mainly coal. Why don't use it in the kiln itself? Because in the kiln we are using plus 5 mm coal. So instead of using fresh coal, why not using this recycled coal? That will bring down the coal consumption. Recycle of fine char in the WHRB, that is being practiced usually. Recycled dust also. See, there are various locations where the dust is generated. ABC dust, DSC dust, then your bag filter dust.
Vishwanduji, kindly complete it fast because we have other
5 minutes?
Yeah, 5 minutes more.
5 minutes, okay. WHRB, use of accretion. Yes, that is a very important development. See that sponge, those who have the sponge iron units with them, always accretion formation is there. And there is a huge quantity of accretion is formed. And usually that is all waste, gross waste. But later on it was found, recently, of late, it is found that it can be used in submerged arc furnaces. It is a sellable product. So that can be done. Cooling water is recycled. Innovations in coal-based sponge iron sector. See, this is the points which can be used for innovative ideas. Hot charging of sponge iron in steel making furnace. See, normally gas-based sponge iron, they are charged hot into the arc furnaces. But coal-based sponge iron, we are not able to do that as on date, till date. So, but technologically it is possible. Only thing we have to do some R&D on this. So now because Ministry of Steel is promising that they will support all R&D activities on that. So that one project can be taken on that. Hot charging of sponge iron in the steel making furnace. Innovation in kiln refractory. We see always 3 months, 4 months campaign life. So a new development in the kiln refractory so that it increase the campaign life. 100% utilization of the waste. Yeah, now I'll come to the steel making, 5 minutes. Routes of steel making, induction furnace, process route, not going into the detail, that raw materials here. We have availability of steel scrap, sponge iron, cast iron, pig iron, coke breeze for that. But again here, we have to use the raw material judiciously. That is important. Optimization of the charge mix. Compositional requirement of the steel grade, cost of the raw materials. Scrap is always costlier than the sponge iron, but on the other hand, sponge iron has a lower yield. Not only lower yield, it has a bad effect on other process parameters also. Cheaper on the one hand, but it has a some negative impacts on my process. Yield of the raw materials, power consumption and power tariff. At some place, maybe where the power is cheap, I can afford to use more of sponge iron rather than the scrap. But, where the scrap is cheap, say in this region, where this import of scrap may be cheaper, available at a cheaper rate. Effect of lining and lining life. Very important. Issues of steel scrap, various issues, but you have to do the analysis. Techno-commercial analysis, always. DRI and its effects on steel making, like whether it is coal-based or gas-based. Gas-based DRI is always at a premium of 3,000 to 3,500, 4,000 rupees per ton. But still some plants use gas-based sponge iron because techno-commercial analysis, it may be possible that yes, that works. Size, then quality characteristics, yield, specific power consumptions, productivity, quality of melt, all these factors I must analyze. Coke breeze. Okay, choice of raw materials and their impact on quality of steel, power consumption, productivity, yield, effect of lining, and cost with respect to advantages and disadvantages. So I'll finish within 2 minutes now. This is just an indicative chart where which we can use for techno-commercial analysis. Say on the one hand, one side it is the raw material and then various technological parameters for evaluation. Yield, what yield? Because yield is important because I am getting the price of my product based on the yield only. Power consumptions, productivity, quality, effect of lining, all these factors you have to meticulously analyzed. And then, see, for Raipur sector, maybe 80% sponge iron use is very normal. But in Gujarat sector, 80% sponge iron may be a very bad choice. Slag generation and its effect. Here, one point which will come into that further discussions also. Because this slag contains more and more of FeO content. So how to utilize that? FeO means almost 80% iron. So why not we either in situ within the process or outside the process, how we can utilize it? That also one area, promising area. Otherwise it is a waste either for the road filling applications or something like that. Although it contains FeO. Cost drivers. So I think I'll finish it. Value addition of steels. That is also one point we have to think of. That here I have mentioned one thing. That always we speak about that high phosphorus, high phosphorus, high phosphorus. There are certain steels which requires high phosphorus. And these are used in automobile sector. Free cutting steels. They require high phosphorus, high sulfur. We can think of making those great steels also. Thank you very much for giving me the time for my presentation. Thank you.
Thank you, Vishwabandhuji, for introducing about the technologies and giving details about the effect of raw material on the productivity and all. As we have a very, you can say, limited time, our next speaker is Mr. H.S. Tripathi. He is Principal Scientist and Head of Refractory and Traditional Ceramics Division, CSRI, CGCRS Institute. And Dr. Tripathi did his B.Tech and M.Tech and PhD in Ceramic Engineering from University of Calcutta and did his postdoctorate research at Boston University. He has more than 20 years of experience in the field of refractory and published around more than 50 research papers and has 6 patents in his name and guided around 2 PhD candidates. And he will be speaking on one of the project which is going under the R&D project going under Ministry of Steel, the development of cost-effective refractory lining material for induction melting furnace suitable for the production of quality steel. And this project is jointly, you can say, done by this NIST and CSIR. And they have done, you can say, already lab trials has already been done, and they're in process of going for the pilot plant trials. And later on, this industrial trials will be taken. Now, I'll request Mr. Tripathi to take it.
Okay, good afternoon, everybody, and thank you, Panditji. So, can you hear me? Okay. So, this now I think it's okay, na? So, the title of my talk is the development of basic ramming mass for induction furnace enabling refining of steel. So just please excuse me because quickly I just prepared the slide. Maybe some information may be missing in the final slide. So actually we have carried out this work jointly with the National Institute of Secondary Steel Technology. Basically I am a ceramic engineer. I don't know too much about the metallurgical portion, and that's why our Mr. Vishwabandhuji and Bhakti Sahab is here. So that's why we jointly worked CSR, CGCRA and NIST to develop a ramming mass. Using that ramming mass, you can refine the steel, or you can make a good steel in the induction furnace. Just this is a brief outline of my talk. I will not take too much time. The steel making through induction furnace Indian perspective already, things are discussed, and refining challenge in induction furnace, and then what is the refractory challenge, and then I will show you some experimental work and the developmental work in ramming mass and results and discussion with some trial. All the trials have taken in this NIST laboratory induction furnace. So this is well known. So blast furnace, electric arc furnace and induction furnace, and although this is in the targeted steel production capacity in 2030-31 is 300 million tons, and in that case the induction furnace route they have a good contribution in the in this capacity building through the induction furnace. So right now the induction furnace mostly use the acidic ramming mass, and using the acidic mass, if you need a good quality steel, so you have to remove the phosphorus level, and if you remove the phosphorus level below 0.05%, then the slag basicity should be very high. So whatever the flax you will use, the flax also contains considerable amount of alkali or alkaline earth metal. So the slag basicity should be high, so then the presently the silica ramming mass cannot withstand the severe refining action. So this our target is to develop a ramming mass. Then it may be neutral, it may be the basic ramming mass. So we develop that typically the basic ramming mass, the magnesite-based ramming mass, and what is the most important is this corrosion resistance against the basic slag, and erosion and abrasion resistance, and the thermal shock resistance. If you develop then we just initially started work with the magnesite-based ramming mass. The problem is the pure magnesite refractory, they have a good, very low thermal shock resistance, so the spalling resistance. Then the main target is develop a basic ramming mass and improve its thermal shock resistance, then automatically you will achieve the goal. So you see that silica ramming mass, it may not be suitable for refining, the cost is low. Then there is neutral ramming mass is available in the market, that is mainly the alumina spinel type of ramming mass, the cost is very high. Then our target was to develop a magnesite based on the basic ramming mass, but the problem is that this spalling resistance or thermal shock resistance is poor, so you have to improve the spalling resistance, then we use some spinel or chrome into the bath to improve its thermal shock resistance. So you can see the, I think you cannot see the bottom picture, because now whenever you use some spinel or so you can improve the thermal shock resistance. From the picture you can see. So for all this work we use different types of magnesia, different source. Initially we started with Chinese, then there is some problem to get the Chinese material from China, because they stopped about most of their Chinese magnesite plant due to this atmospheric pollution. So then we shifted to Kumas and PPL, the different source of here. So and then the spinel also, we use the Almaty spinel, and to reduce the cost also we have tried the in situ spinel in the batch. So that means if you use the alumina, you can develop the spinel in situ, in that case the cost will be low. And we have worked on some binder system also. So this is a basic experimental layer. So batch composition, mixing within the laboratory level, we just mix, you use some, although it is a dry ramming mass to give a shape. So that's in the laboratory, we just temporarily use some wax as a temporary binder, and then hand molding, demolding, firing at temperature, and then characterize it. So I will show you some different type of magnesia and preformed spinel, calcined alumina. These are the typical chemical composition. So 96.5 to 96 to 97% purity magnesia. That is all the magnesia is commercially available. So you used it. So when you use some spinel, you can see there is a improvement in the strength. There is a improvement in the thermal shock resistance also, but there is a slight decrease in the strength when you use some spinel. That's why to overcome these things, we use some binder to improve the mechanical properties. And we found out that the 20% spinel may be the optimum for this type of work. So this magnesite, 80% magnesite and 20% spinel may give you the optimum result. And then we have tried the in situ also, that instead of pure preform, we use in situ spinel with some binder also. Then if you use the binder to densify the material and to give the better strength, then in other way it will decrease the thermomechanical properties or the load bearing capacity and all these things. So optimum binder, we optimize the optimum binder also. Now we see that typically, so this is a thermal shock, how we measure in the laboratory. We make some cube and put it in the furnace, but it is just 10-minute heating and 10-minute cooling in directly in the forced air. So the 1400 degrees centigrade to room temperature in forced air, and then at a regular interval we observe it is in the the structural, if there is a structural falling and all these things. So when we use the pure magnesia, you can see this magnesia sample, the pure magnesia sample is broken, but when you use some amount of spinel in the composition, it can keep even up to after 20 cycles also it can retain its shape without any structural damage. Okay. Now based on these things, based on our this laboratory findings, the NIST, we have carried out the trial at National Institute of Secondary Steel Technology, and so the first we started in 5 kg induction furnace in the last December 2016. So you see some of the quickly I can pass. So at that time, so we got about hardly 4 hits in that initially, because the 5 kg induction furnace cavity size is very small, so when you put the flux, instantly the flux can react with the refractory. So, and then maximum 49% or the 50% DRI we used it. And then after 10 kg we just decided to go for a 20 kg induction furnace. We take the trial initially, and the tapping temperature is about 1640 to 1650 in that day. And up to 80% DRI we charged it. And then we further modify the composition. You can see that the lining line is damaged after 6 hits. Then we further change the galvanometry, modify the binder system, and we come to these things. now you see the gist of these things. So this project was sponsored by Ministry of Steel, and our parent organization CSR also sponsored a good amount of money to do this work. And then in the PRC, in the project review meeting in last June 2017, they give us a target. So in the 20 kg laboratory induction furnace, if you can achieve 8 to 10 hits, because at that time we got about 4 to 6, so if you can achieve 8 to 10 hits in the laboratory induction furnace without any repairing, just continuous the refining and casting, then maybe in actual practice we can get the desirable heat. So now we work with these things. Now you see in all the this DRI content is 79%, or 80% is DRI, 20% is the scrap, and on an average we are getting 13 to 16 hits, and maximum 19 hits we have achieved. This is the year. So maximum our target was 8 to 10, we achieved on an average 13 to 16, and maximum is 19, and this 19 hits is reproducible. It is not like a single year trial. We repeated the trial and we got the same 19 hits in the year. So this is just few years. That's how I don't want to waste your time. Just some of the things. So Magal, then just come to the summary. Just if you can develop the magnesia with some spinel containing dry ramming mass, you can refine. That's finished. That's you can refine and you can reduce the phosphorus content to a desirable level. And using these things, I think we have taken the trial with 20 kg. Now we installed the 50 kg induction furnace in our lab. So we'll take the trial in 50 kg, and then it needs an industrial trial for its commercialization. Thank you.
Thank you, Tripathi ji. As Mr. Tripathi said, that results are quite encouraging in the lab trials, and we hope that we will get very good results in the industrial trials also, and industry will definitely get benefited out of it. As you have heard now from the two speakers from the institute, now next three speakers are from, you can say, equipment supplier. Shri Avinash Bhandari ji here, he is a joint MD, Electrotherm India Limited, and he is not going to make any present, he will just give the opening remark and recommendations for the MSME sector, for the implement of this sector. And question and answer session we can take up at the last moment, as the time is very limited to us.
So a very good afternoon. Because of the paucity of time, I'll keep it very short. We at Electrotherm continue to believe that the economy over the next 10-15 years will grow at a very fast pace, and by 2030, another 15 years, it should touch about $10 trillion. We also believe that the steel production and consumption will move very quickly from about 100 million tons right now to about 300 million tons. Consumption will not be an issue. Having said that, we believe that there will be a short-term mismatch between demand and supply. Any capacity which primary producers, the main producers, create through the blast furnace route, especially for the long products, will take a lot of time, and therefore the demand over the next couple of years, at least 2-3 years, will have to be met through the secondary route. And therefore, it is important that the government, the morning session by the Honorable Minister was extremely encouraging, but it is extremely important that this scarcity or the shortage in supplies for the long products, which can happen over the next couple of years till the new capacity by the main producers come up, will have to be matched by the secondary steel producers. Now within the secondary also, given what has happened to the electrode cost, I believe induction furnace is the only solution. And therefore, if government can give certain, my recommendation here is that, today a million and a half also kind of a size for induction melting furnace plant, integrated induction melting plants have become a reality in the country, and therefore some incentives can be given to set up large mini steel plants through the induction route. Let us say we can fix up a base as maybe 0.3 million, 0.5 million, something like that. And then some incentive is given for setting up a greenfield induction-based steel plant, because this capacity can come up very quickly, and the long products can be rolled out very, very quickly from there. My second recommendation to the government officials here would be that if some kind of a, if the new capacity has to be created quickly, then the time should not be lost in the environmental clearances. And if there's some kind of a green channel mechanism can be created, because the route is very clearly understood by everybody. The route is understood by the ministry, the route is understood by the Ministry of Environment, it is understood by GPCB, CPCB, all the institutions, and therefore if some kind of a green channel can be created for the induction and rolling kind of plants which come up, so that the 6 months to 12 months which get lost in getting the permissions, that can be shortened and the plants can come up very quickly. We also believe that there is a need to invest into beneficiation in India. A huge amount of pelletization capacity has come up. The pelletization capacity in the country is, I'm sure all of us know, that it's almost reached about 85 million tons, but there is not a matching beneficiation capacity. And beneficiation will be extremely important to be able to really use the low Fe content iron ore. And if government can support that through the R&D, promote R&D for beneficiation, low cost, efficient research and development in the beneficiation area. Obviously, if the production through the induction route has to increase, then scrap will become more and more scarce. Today there is a 2.5% import duty on the scrap, and if this can be taken out and the cess on coal can be rationalized, then the cost of this route can remain viable and continue to deliver more and more long products to the nation. I think this point has already been discussed earlier, but I would still make a last mention that provide some kind of a rebate incentive on pollution control equipment. This is the area where huge amount of work has happened in the induction route over the last 4 or 5 years, but still lot more needs to be done, and therefore if some kind of incentivization rebate happens on the pollution control, then I am sure this entire sector, induction sector, will comply much better to the environmental norms set by the departments. Thank you very much.
Thank you, Bhandari ji. I think a lot of recommendations are related to the, you can say, government. So ministry will definitely pursue all these matters with the different ministries. And next speaker is Sridhar Rao. He is Vice President, Danieli India Limited. I now request Mr. Sridhar Rao to make the presentation.
Friends, hello. Yeah, we were told as technology suppliers how we can support the MSME sector. So this is one of the areas where our company has been working quite strongly on developing technologies which are appropriate for the medium sector to a micro sector or even large sector. So one of the key developments which have happened in recent times, I would just like to highlight that, which is we were already hearing how from Dr. Bandyopadhyay, how the process of casting and direct rolling is one of the important developments which has taken place. So we have an actual case here which has been developed over the years. In fact, I think it took several years to come up with a concept where we could cast and roll directly. And then the concept was extended to the mini and micro steel sector, where capacity is of the order of 300,000 tons. And this process consists, in this case, of a direct charging of scrap into the preheated scrap into the EAF. The preheating of the scrap will give substantial benefits in the energy consumption. And then the steel is going to the ladle furnace and to the caster. So there is steel now in every phase of the production process. You have the steel being charged continuously, you have something being melted, and then in the LF, and then the caster. And then this from the caster, it is being cast directly and rolled without any cutting. So this adds to the further to the benefits over casting and direct rolling. In fact, when it is casting and direct rolling, it is usually not a case that you have 100% all the billets getting rolled. Here the attempt is to make it close to 100%. And one of the benefits here is on the yield, the major benefit. We are talking of the yield of the order of 99% plus. So I'll just go through this thing quickly. This is pertains to the first installation which we had in 2009. It was started up in September 2009. The target was 41 tons per hour production, which was achieved in about 2 months' time. And then further improvements took place. Over the next 3-4 months, it could reach 45 tons per hour. And then over the next few years, continuous development took place. So every year some improvement was being done. So by December 2015, the figure of 51 ton per hour also was reached. So here is a process which is quite possible to start with like 41 ton per hour, somebody who needs that. And the same process by some small changes can also go to 51 ton per hour. And now the same customer has ordered another unit which is rated for 55 ton per hour, which is just started. So this is a repeat customer. This is CMC in Arizona, first plant, and the second plant they put up in Oklahoma. So this 2017 we have started the second plant. Another example of this, when this development took place, you will see the timelines here. It starts in 1995. Then up to 2000, the whole basic technology was being developed. And the first tests were done in our own plant. We have a plant in near Udine. And in that plant, that first tests were done where a capability of producing even 90 ton per hour was demonstrated. However, that plant is actually a specialty steel plant. So the further thing was not done there. It was discontinued after that. And then the process started of developing the technology for a micro steel plant of the order of 275,000 tons was the target at that time. And this definition took a few more years, and finally we saw that startup in 2009, what was the thing. And before that, there was one more trial done in a plant in Greece, which had multiple strands. So one strand was converted for doing this, endless casting and rolling process, which was feeding directly into the rolling mill. And the third case I want to give is now the further scale up. The next level of development took place recently in 2017-16. We started up this plant, this in IISc in Egypt. This was rated for 75 ton per hour. This is a contracted for 75 ton per hour. But very soon it was demonstrated even 80 ton per hour is possible in the same plant. So now this is the evolution in IIC, how it took place. The contracted was 75 ton per hour, which was achieved in about 1 month's time. Started in September 2016. By October 2016, not even 1 month, it was less than a month. The 75 ton per hour was reached. And then further, after a few months, within the same month, even 84 ton per hour was demonstrated. Then after 2-3 months, then further test was done at 90 tons per hour. Now this customer also has one more plant, which has just been started up, which is now rated at 90 ton per hour. So all this we are talking about production from a single strand, casting and rolling directly with no cutting in the caster. All the cutting is done at the end of the process just before going on the cooling bed. There are some very innovative technologies involved here, which also includes a very short cooling bed. So you have cut to length just before dispatch, so you are not doing multiple handling. So many of these concepts we can examine. In particular cases, this can be applied. Now the next step in this evolution is going to be for 100 ton per hour, which I think next year there is a plant coming up for that. I would just like to show you the short video of this plant. This is the ladle going to the caster, and in this plant the casting is done for 23 hours every day. The there's no interruption, it starts, and for 23 hours, the billet is being produced and rolled in line. And then it is shut for 1 hour, during which any maintenance in the rolling mill is done. Usually it's a change of program or some maintenance, change of rolls, few things like that. And then again it starts and again runs for 23 hours. This typical running, though they have actually run for more than 35 hours also, some few cases. The process here is continuous cast, is with submerged casting. The controls are all from one control pulpit, which is common for the rolling mill as well as the caster. So it is a very, very integrated operation. We are not talking now of continuous casting and rolling separately. This is one process now. Okay. Okay, this is, just before I close, I just want to introduce one more topic, just to introduce. We were hearing a lot about induction furnaces. Of course, we are not in the induction furnace industry. We are primarily into electric arc furnaces. I feel that with what we heard in the morning, now the internal generation of scrap will also go up. There is going to be a quantum jump in the availability of internal scrap. Maybe not now, but next 2-3 years maybe. At that time, I think again the electric arc furnace is going to become more relevant again. And we have some techniques to, one of the issues with the electric arc furnace is the flicker, what goes back into the system, what harmonics go back into the system. And there is very expensive equipments done to compensate for this. But now we have some techniques coming in which have been tested, which are being developed now, which can address these issues. Just I want to show you or we can discuss this offline. We have something called Q1, which takes the power from the system and it does a rectification and then again converts back to AC to supply to the caster, to the EAF. In the process, what we are doing is we are isolating the furnace from the main grid. And the main grid is no longer that much affected from this. The dirty part and the clean part is separated out. There have been good benefits of this technology which have been tested over the last 2 years. The benefits include reduction in power, reduction in electrode consumption, very strong reduction in electrode consumptions. So these are some benefits which we can look at eventually when we are talking for electric arc furnace. Thank you.
Thank you, Mr. Rao. I think that technology, what you talk about, the endless technology, this is, if you see the MSME sector, I think they have a capacity, production capacity around 25 to 50 tons. If something can be done for the 25 ton to 50 ton capacity units, that would be highly helpful for this particular sector, I think so. Now, our next speaker is Shri Didi Kapoorji. He is Joint MD, Chorus Engineering Solution Private Limited, and he will talk about the new products and new innovative technologies for the MSME sector.
Good morning, everyone. I am working in the steel industry since '69, starting from Allied Steel Plant, Durgapur. And I shifted to the secondary steel today called secondary steel, at that time called mini steel. When a lot of scrap was available and a number of electric arc furnaces were installed all over the country and being installed rather at that time to melt the scrap and provide the steel to local markets. This was a very, very interesting phase, and my mentor, Mr. M.L. Ahuja, who is today 87 years old, he convinced me to leave my government job from Allied Steel Plant, Durgapur, and come to Hisar, very near to the Jindal strips at that time being called. The name was Jindal strips. In front of them, it was a backward area, and Haryana government and one Polysteel Bhavnagar from Gujarat, a joint sector enterprise, they were setting up a 50,000 TPA electric arc furnace plant to produce billets for supplying to the rolling industry, and later on this plant put up the rolling mill also. My association with this work, coming from working in the shifts in the main steel plant and coming to this private sector plant with the greenfield and having an opportunity to build this plant and learn from the how the plants are constructed, because when I joined Allied Steel plant, it was already in operation and I was working at that time in maintenance. So this plant was started, but after it started, this was having, the continuous casting was a new technology and it was being successfully followed from Mukand downwards and even in this plant. But there was a big problem of the power. Now the power, there was a struggle between agriculture sector and the mini steel sector. So government will invariably give power to the agriculture sector, and number of months, maybe it will be 6 months, you are not getting power. And it was very difficult to work at that time. And for some period, I became a chief engineer of a cast iron pipe plant of Kesoram spun pipe. But very soon, by the same plant of Haryana Polysteel, I was called back because the industry was now again, you see, improving. But on that time, Mr. M.L. Ahuja, he was working as consultant in this field of mini steel plants. He again convinced me to join a consultancy company at that time with the name of Singh and Associate. I worked 28 years in that company. I was director engineering, and on my retirement we started Chorus Engineering Solutions Private Limited with a very different concept of contributing to the society. We called it payback to the society, which people call, and we virtually started an engineering company. Today we are having about 200 people, sometimes we had 300, but then the bad period of last 5 years, today we have about 200, and I have been working on various projects, maybe more than some 350 projects in my lifetime I must have done. And I am thankful to Steel Rollers Association to give me an opportunity to have an eye contact with many of you, because most of the time we remain busy in our design and drawings work. I have got some, from my experience, some of the ideas for your sector. This sector is known for its product portfolio as rebars, then light and medium sections, then alloy and special steel section is also a part of it, and it is covering almost 70% of the alloy and special steels of this country. And some of the other areas are there, yes, people in cold rolling, galvanizing, color coating, wire drying, bright bar, etc. But I want to, when we say generally, we say this area is for long products. So most of the time we say this is most suitable for long products. Now I want to say yes, this is to the large extent it is okay. But I have an idea that have a look at China. They produce narrow strip to the tune of 40 million ton per annum. Narrow strip, when we say, it is the strip up to a size of about 18 inch means 450 millimeter. I firmly feel that today a big strip mill is put with a cost of 2,000 to 5,000 crores, and the capacity of those mills are from 1.6 to 5 million ton. This is the mills which can be put very economically, and in the secondary steel sector, there will be large demand of the narrow strip. This narrow strip, I want to tell you what are the products made out of this narrow strip. Narrow strip is made up to this width from 1 millimeter to normally up to 6 millimeter, but can be made 12 millimeter also, but normally up to 6 millimeter. This strip is used for making pipes, and today to a very large extent for making hollow sections, square hollow sections, rectangular hollow sections, elliptical sections, many shapes of the hollow sections. Also, the strip is further cold rolled, and we make again thin tubes, elliptical tubes for let us say transformer heat exchangers and many heat exchangers. And also the cold roll products, they are used for automobile components by fabrication, by press punchings and other things, large extent. Then when you go to the airport, you will see most of the product today is not angles, channels, it is all tubular or hollow. You will see hollow section has got very good bending properties. That is why today you will never see an angle channel being used in this function.
Sir.
So
Kapoor
if you
sir.
go to roadside, you will see lot of side guards being put. Very large, whole country, all these roads, highways, there are the product is used by corrugating and fixing with the side post as a safety guard. This is also a very large requirement.
Kapoor
Then
sir.
the lighting poles. Lighting poles is another big application. One of my customer here, he supplied lighting poles for the whole of Nepal country. So this is a product which we have to have a look at. We have
Kapoor
to
sir,
have a
I
look
request
at.
you to complete within 5 minutes because
Okay,
everybody
okay,
is.
please. Then, out of the various technologies which are coming up, we have very successfully applied the direct rolling, and that too of billets of 130 millimeter square from 9 to 12 meter long, not small one, not 100 millimeter, 9 to 12 meter long. And we are having a vision that yes, endless casting and rolling, which Mr. Rao, he has explained. We are doing one project in Kurnool, in Hyderabad, of a plant of 400,000 TPA, where endless casting and rolling will be used, but somehow there are some limitations in that technology from the quality of the steel to be used. And we are thinking of another intermediate stage through our own efforts, that now we are succeeding from 9 to 12 meter long billets of 130, which is quite big. We are thinking that some increase of speed from the caster, and also insulation of this and putting the plant near to the continuous casting. We are thinking, is it possible to use 24 meter? This is a figure which we are planning and thinking. That direct rolling of 130 millimeter square, 24 meter. We are thinking on that. So this is a technology, endless casting, which he has explained. It is suitable only for the secondary steel sector, because its production capacity is not that high as compared to the main steel plant. They have capacity 150 ton per hour, 200 ton per hour. This may be, as he has explained, it started from 300,000 at Arizona, very successfully working, and now we are already installing 400,000. Now they are talking 165,000. 165 square billet also to be cast at 6 to 7 meter per minute and have a capacity maybe as large as about 90 ton he is talking. So this will be the technology which will be there. Next, we are thinking some research work has to be done on the scrap preheating. It had been used for the electric steel furnaces. We are thinking that some places the corn steel process has also given very good results, where the charging to electric arc furnace, at least those units can start with such a process, where with the flue gases going from the furnace, it is possible to utilize the energy and heat the scrap to about 900 degrees centigrade. The plant which is showed at Arizona, it is already doing at 900, and these are little special electric arc furnaces which rotate around the point of scrap charging. They move only around that. And I feel this scrap processing, because the scrap will get generated a lot in the next maybe 10 years, the generation will start that you have to consume it. The generation will be very large. At that time, I feel this technology, before that time comes, we have to develop for the scrap preheating. And then as the disposal of our solid waste. This is a very important thing. I went to ABS, a company of Danieli in Italy. There we found that the whole of this slag, it is first stored for 3 to 4 weeks. There is a reason for that, because if we don't do that, reconditioning of that, or you can say that under the various atmospheres, it is given some time to become better. After that, it is being crushed and segregated with the magnetic separation of this and made into an aggregate. This aggregate is used as per the government regulation all over for road making.
Kapoor sir, complete.
Yes, sir. Just so this aggregate is used for road making. If we religiously use the item for the purpose we have, we are also making from the fly ash for Jindal at their Angul works. We have set up a plant of sintering the fly ash. Again, in place of making bricks, it is making aggregate. Again, this aggregate has to be strictly used for the road making, not for other building construction. So, thank you so much. Thank you so much.
Thank you, Kapoor sir. Now the session is open for the questions. We can take up to 2 or 3 questions. Before taking up the questions, I just want to say that if you will implement any of the technology, just to run the technology, we need that the manpower, whosoever is working on the shop floor, that should be properly skilled. Because what we have seen that while visiting the units, that even under the UNDP project, lot of, you can say, energy efficiency implementation has been done, but they are not able to sustain it because of the, you can say, lack of the skill level of the manpower. So session is open for the questions. We can take up 3 or 4 questions maximum.
Yes, anyone would like to ask any questions for our panelists and our chairman?
एक्सक्यूज मी, मेरा क्वेश्चन ये है कि इंडक्शन फर्नेस की सबसे बड़ी प्रॉब्लम ये है कि इसमें फॉस्फोरस कंटेंट थोड़ा कंट्रोल नहीं होता, जैसे आर्क फर्नेस में होता है. क्या कोई ऐसी टेक्नोलॉजी आ रही है जिससे कि इंडक्शन फर्नेस में भी हम कंट्रोल मटेरियल बना पाएँ?
तो अलग अलग प्लेटफॉर्म पे हम लोगों ने ये डेमोन्स्ट्रेट किया है, बताया है. मिनिस्ट्री ऑफ स्टील के अंदर भी प्रेजेंटेशन दिए हैं और करीब करीब ये प्रोसेस आज 4 साल से फुल्ली एस्टैब्लिश्ड है. हमारे खुद के भी स्टील प्लांट के अंदर वहाँ पे अलॉय स्टील बन रहा है. तो आप जब भी चाहें हमारा प्लांट विजिट कर सकते हैं और वो जो प्रोसेस यूज़ हो रहा है जिसके अंदर गारंटीड सल्फर फॉस जो है 0.03, 0.0 इवन 0.02 लेवल तक ला सकते हैं, वो दिखाया जा सकता है.
I will add one more thing to that, phosphorus removal. See, the conditions for removal of phosphorus, there is a one point, only that lining part. Most of the induction furnaces, they are using lining, acidic lining, and it is very, very difficult to control the phosphorus in acidic lining. And basic lining, it can be easily controlled, but then it is a costly thing, and then continuous operation, it requires continuous operation and all that. But now, as we have taken up a project of development of such a lining that phosphorus can be reduced to admissible levels as per BIS standards, and without going for basic lining. That development work is already almost in the final stages, and maybe in another 1 or 2 months that will come up. Yes.
Yes, can we have the
Flux
mic
has also
over
been
here?
developed. I think Mr. Bagchi will stress upon that.
NIST along with NML, Jamshedpur, has already worked and developed a flux suitable for dephosphorylation. And our dephosphorylation index within the furnace itself, added under the silica lining condition, dephos to the extent of 50% we could achieve. And further, with the development of this particular lining with CGCRI, I think that part is also over. We can go up to 70% dephos with some additional flux input. The total additional cost for the flux addition would be around 300 to 350 rupees. That's all.
Thank you, sir. Yes.
Any other question?
Any more questions? Yes, we have one question there. Yes.
Mr. Bagchi, I'm J.L. Goel. This free 50 rupees will be per ton or the total cost? Per ton. But you know that the 350 rupees per ton is a very high cost. And one more point, you have told that it will be reduced by 50%, but on what level? If the opening cost is 0.08,
Yes.
if you bring down to 0.045 or 0.05
Yes,
at a
yes.
cost of 350 rupees per ton,
Yes.
that is not acceptable for if you are making an alloy steel.
Then what is the solution for
Because-
0.8 for phosphorus, 0.08?
So that's
You'll
why
have
I'm
to-
asking
You'll have to incur some cost to reduce the
because
phosphorus.
if a commercial grade which you are making in an induction furnace, if you add in 350 rupees per ton, I think it is a very high cost and you will not. No,
Yes.
That is not the question. I just asking Mr. Bagchi that 350 rupees per ton, if you increase the cost or for the dephosphorylation
Okay.
for a
Then
commercial
what is
grade
the
of steel.
solution? Just tell me what is the solution.
That's why
Yes. So
I want
to
solution
develop,
from
to
you.
get some benefit, you must incur some cost. Give me the sponge up to 0.05. Then the sponge will be costlier. Then
Yeah.
you say, you are getting low phosphorus sponge, you are
Goel
getting
sahab,
a
aisa hai.
high cost, I'll not incur. So you'll have to incur some cost somewhere to have a quality product.
Sir, when you are making a
There is
commercial,
no substitute
Yes.
of no substitute of spending
can we
money.
have this-
You don't want to spend money, you get
Gentlemen.
everything quality. No, it's not possible.
Goel sahab, if to make the quality you have to pay, and you will get the premium of that also. That is there. Any other questions?
Sir, this.
One question.
Yes.
Can I ask one question, please? To Mr. Rao
Okay.
from
This will
Danili.
be one last question, sir, please.
Yeah. To Mr. Rao from Danili. You said that this continuous casting can be possible only in electric arc furnace. Is there any possibility of this continuous casting of 85 tons, 100 tons, or that 23 hours casting in induction furnace route?
See, we are
Sequence casting.
right now one plant is being started, is under commissioning in Vietnam, where the steel making route is from induction furnace, and we are testing out this concept of endless casting rolling with material coming from induction furnace.
Thank you.
Thank you. With that.
Yeah, and one another question. I think this is the last question. But we can take now.
My question is with respect to the presentation made by Honorary Minister of Steel and and the secretary. I hope some of you can convey it. First of all, I would like to thank, I'm the user from the contractor side, for the ministry for bringing out a notification and order in 2016, removing the classification of the steel and only specifying the quality of the steel. But in spite of this, all government organizations, including NHI, RVNL, railways, all these even Nuclear Power Corporation specify so-called primary products. And we are prohibited from using so-called secondary product. I'm calling so-called because that terminology is no more valid. And all these secondary products which are produced under Thermex process, I checked the quality is very good. Today there are facilities available to see that chemical composition, strength, deformation can obtain within few minutes. Testing facilities are available. In spite of that, every government organization is prohibiting use of such secondary steel. And I've written a letter to 6th Ministry, including Minister of Steel, including PMO, including Mr. Nitin Gadkari ji, everybody, 6th Minister have written in February, but no response. I've given a copy of that letter to Ruchita Chaudhary ji this morning. So you have to take, just like Thermex, they audit all these secondary steel manufacturers every 6 months. You must see that, government must see that why the government organizations are not permitting. Our aim is to produce quality product using quality steel. In this, we need the help from all of you. Thank you.
Honorable Secretary has already addressed this question, I think so. So this will be taken care of.
All right, thank you so
much. Thank you very much.
Can we have a huge round of applause for our chairman and our panelists? So now, ladies and gentlemen, we'll be breaking for lunch. We'll converge in 30 minutes from now. So we request all our guests to be back here in 30 minutes. Thank you. Enjoy your lunch.